Okay.
Reintroduce.
Yes, I'm Rich Halverson, your instructor here for ITS128. This is the first day of class, and here at Capilano Community College, everybody's here. And I'm going to introduce you to the class today, show you where everything is on La Lima, and go through the slides for Chapter 1. So let me share my screen here. I will share this screen, and I'll do that. Share. You can't see that at home. All right, so here's my screen. Let me put this down here, and let me bring up La Lima. And here we are. Let me see. I'm going to put this right over here. I am on the wrong one. Let me log out of this. Log into. This is my student version account. And so we're ITS128. Okay, so this is the syllabus. Click on overview here. And the face-to-face, if you're going to attend this class face-to-face, it's where you are all here today. This is where it is, where we are today. If you're unable to come to class, you can go to this URL and you join the meeting just like I've joined the meeting. I'm hosting the meeting. And when you do this, you can actually, you can ask questions too. You can say, excuse me, or whatever. When you do, if you do log in remotely, you can turn your camera off. You don't have to have your camera on. If you have your camera on, sometimes people at home will see you. Like if you make a little noise, they'll like see you instead of me. And so also you can mute yourself. So you mute yourself, and then when you want to ask a question, you can unmute yourself. And that way, if the dog starts barking or something, we don't all hear it. All right, so somebody just joined us. So my office is in Copico 207, and my office hours tentatively are going to be Mondays. I'll be here at, I have to be here at 4 o'clock because I pick up another instructor and we go over, we're taking a class at Manoa. And so I'm going to come beforehand and probably work on one of my other online classes. But so I'll be upstairs. And then before my 148 class, I'll come early. My 148 class is at 1:30. No, it's at 1:45. So, if you plan on seeing me, it's always a good idea to text me. And then for sure sometimes if I'm lazy, I might not, but if you text me and say, hey, I'd like to come and see you today, that's fine. You can text me, tell me you're gonna, and if you don't show up, that's fine. I'm not gonna hold it against you. I mean, I was a student too, whatever stuff comes up. So don't worry about, that kind of stuff either. And I hope you won't worry about that with me too. So, and you can always get a hold of me via email or text. If you have a short question, you can text me. If I can answer it right away, I get it everywhere. I get it on my watch. But if you have a longer question, or if you want me to look something up or something, you can send me an email. And now I get every email whenever you send it. I look at it, and I might not respond. And oftentimes, there's lots of reasons why I don't respond. I could be in a meeting, and I get attention deficit disorder, and someone's boring up the department chairs up there, boring us or something. I check my email. Now I don't want to be replying to you, but okay. So if I'm ever if I'm ever slow getting back to you, especially if you have something you need to know right away, and I'm slow getting back to you, just email me back and saying, hey, did you get my email? Or text me and say, hey, did you get my email? And that's a good way for me to go, oh, that's right, and then I'll respond to you. Either way, even if I haven't figured out the answer yet, I'll respond to you to let you know where I am, if that's what's happening. The textbook is this Visual C#. It's a pretty good textbook. And so you're going to need a Microsoft login for Visual Studio, and that's what you do. Like if you want to download the community version of Visual Studio, which is perfectly fine. That's all we're going to use. and so it's free. So when you come and use Visual Studio in the classroom in these computers, it'll like work for a month or something, and then it's going to make you sign in. And all you got to do is sign in using your login. I mean, it can be any sign in. You can make a new one. I've got like 3 of them. Okay, I forget, and I make in fact, I have 2 of them with the same email address, so it's okay. It just I don't know. It's like it wants to know who's using it or something, but it's free. Yes.
Sorry, question.
Mhm.
Is there a big difference, or is it just like free versus paid when it comes to Visual Studio?
Yeah, there's Visual Studio. I think the next one is Professional Edition or something, and then there's Enterprise. There's a bunch of extra stuff for compiling. There's a bunch of stuff where if you're working on a team and you want to integrate all your code together, which is usually what you do on a team, there's special tools for that. Not really. I don't really know of any difference. It's more than sufficient, and I do that on purpose because I don't want anybody to have to pay as little as possible. It's the best thing. All right. So this is the course description. We're just starting out programming, and this is the C# is a regular full-blown production programming language that's got all the object-oriented features of any other. It's better than Java. Java programmer might not tell you that, but there's more stuff in C#. C# came along after Java. Microsoft used to call C# Java, but then when it got to be so much different than everybody else's Java, the Java folks said, "Hey, quit calling it Java," and so they came up with C# and they added some extra stuff. But we aren't going to get to any of that extra stuff in this class. But in the next class, we'll learn some things where you're able to. One team of programmers is able just to put like the name of a method that's going to use in some production thing, and you and your other team are going to write the method. And as long as you make the header thing the same and you hook it up right, then that works perfectly fine. And so there's a bunch of features like that Java is more difficult to do in Java. You can do anything in any programming language. It's just that does the development environment provide an easy facility for that? Does a programmer have to be specifically aware of what he or she's doing, or not? So there's these course competencies and student learning outcomes and so on, which is just basic programming stuff. Let's see. This is my grading. There's going to be okay. Everything's a programming assignment. Okay. There's no like in-class exam or anything like that. So there's going to be probably like 10 assignments or something, and each assignment is like, so if there's 10 assignments spread across this, that's like 4% per assignment. These are just bigger assignments. They're bigger assignments. With these assignments, with these programming assignments, like programming assignment 1, 2, and 3 are going to be all like part of the same thing, and you start with 1, and then you add on to 2, and you add on to 3, and so if you can do it in sequence like that, it's easier. But when I demonstrate stuff in class and I go over these things in class, I'm going to do practically everything in class. So if programming is not your first, if it doesn't come, well, if it's a little more difficult for you, you can always just watch the videos, watch my class, and just do what I do and listen to what I say, do what I do. And in this class especially, that works just fine. You're going to learn that there's like two components now to coding and programming to making Windows applications. We're going to be making regular Windows applications, .exe files, where you have an executable. You double-click on the .exe file, and the form comes up, which is your application, and you can have multiple forms clicking around and everything. There's this division of labor that's coming about now where the designers of the form, the designers of the interface, do not have to be the same, does not have to be the same team as the folks that write the code to do the stuff. So like if you're making a financial system financial software package, you have a team that's making the screens, interfacing with the users, learning about, you know, oh yeah, the variables are this and the outcome is this, and you make everything look real nice and have everything hooked up. It's exactly the right kind of text box and sizes and everything. Human computer interaction. You've read the articles on it, and then you got a whole another team where they're going here. Okay, we're going to give you this number, and we're going to give you this number, and you got to calculate it. Okay, according to this formula here. I don't really understand the formula, but you got to understand the formula, and you code it up, and so you're just writing input, coding, output, and that's it. You're not paying attention to how it looks. Someone else is going to make it pretty, but you like, you know, squeezing a little bit more efficiency out of your program code. Okay, that's more the coder type. You know, I've never really trusted myself to be able to make a nice looking interface. I mean, I could put the text boxes up there and the drop downs, but you know, I don't know. My stuff doesn't look very pretty that much. I don't really have too much confidence in myself to do that, but I am confident in my code writing. I don't think there's any code I can't write. You know, just sometimes it takes longer. But so you're going to be able to find yourself in this class, and if any of that appeals to you, and so that's one reason why in this class in 128, I'm just not as tough on you as far as grading is concerned. I'd like everybody to get through 128. 148, I'd like you all to go into 148, and then in 148, stuff's going to get a little harder. You can decide whether you're going to go to 128. You know, you can get a decent grade in this class and decide, yeah, I got a decent grade and everything, but you know, geez, I know 148 is going to be focusing more on whatever, and so you can decide then. But I also realize that it's like some of you have to take 128 and 148 to be able to do what you want to do, and it might not be, you know, coding the formulas between the text boxes and the output. It's 228 where it really gets, 228, it's different. 228's a little bit more like a traditional programming class where you're going to be doing a bunch of stuff. So 128, 148, and 228 is similar to ICS111 and ICS211. The difference is we use C# in Visual Studio. 111 and 211 uses you know, Eclipse and Java or something like that. And you just don't spend as much time on the interface. You don't spend as much time on the designer forms and making the interface convenient for the user, because Eclipse, because those other IDEs are just not as good at that as Visual Studio. So anyway, so that's that. Here's what the schedule looks like, and this is very similar to the schedule last semester. In both of my Tuesday, Thursday classes, I've got Monday, Wednesday here. By the way, in 2018, January 8th was on a Monday, so you can tell where I got this. Anyway, but so the days are wrong, but the dates are correct. This is spring break time, and there's another little holiday here, but we fortunately have 32 class periods in this class, in this particular Tuesday, Thursday spring semester class. You know, you have 30 or 31 or 32. So we're going to be able to get a little bit more into Chapter 9. Chapter 9 is databases, I think. No. Never mind. We're going to be able to get into Chapter 10. We're going to be able to dabble in Chapter. I didn't put that here because really this class ends at Chapter 9, and databases comes in the next class. But so what I've done is I've like spread this out a little bit on the syllabus. But really we're going to have like maybe three class periods, or two at least, to dabble in some databases. at the very end. So just like one assignment, and what we'll do is we'll take some assignment where we've already made it up, and it'll be like displaying some stuff, or there's an assignment where you're going to create a friend file, and it stores all your names of all your friends and sorts them and stuff, and you can unfriend people and so on. And the last step will be convert it from a text file, the quote database, not a text file of your friends, but a database of your friends. And so we'll see that. So we'll have time to do that. It's probably not going to count that much for your grade, but it's kind of interesting to learn that. And you can kind of see we're going to start where we don't read any input from any file or anything. It's all input is from the user. In fact, in the very beginning, all the input is going to be clicking buttons, and then we're going to get into inputs where the user types in stuff in a text box. And so that's the input, does some processing, does some output, and then we're going to get into reading files. And reading and writing files. And once we can read and write files, we can do a lot more. So this is standard stuff. I'm not sure when the hours are for Copico Learning Lab. They changes every semester, so I'll have to update that. I'll have to update the days here. So, all right. So that's this class goes till 4:30. So that's the syllabus. The next important part of Laulima here is this resources folder. And the resources folder has the class videos. This is where the class videos are going to go. So like this class video, it's going to go in here. So when I'm done, I'll upload it, and later on this evening, or maybe just half an hour later, you'll see it. You can see it there. And I think I'm going to send. I got to send out an email because just to let everybody know, there's people that are. I'm sure there's people that aren't here, or maybe there's not, but I think there's people that aren't here today. And so, just to let everybody know, to remind everybody that if they do miss class, they are able to get everything out of it. And also, if you're gonna miss class, if you're gonna miss class in a way where you're absolutely not gonna be able to do any work, like you're gonna go on a Safari, I don't know, where you're not going to have any online access, you can't submit anything, then tell me, talk to me. But if it's something like you're sick, or you got to go to a wedding or whatever, you don't even have to tell me. Just watch the video, just keep up with the assignments. Everything's going to be online and everything. So that's, you can treat you. Not all the instructors are like me, but more and more so, and also the later classes, in graduate school, they only give A's and B's. Okay, so but as you get up in your senior year, your junior year, like it gets more that way. It's you just, and with me, the way I teach, people that don't pass are people that don't finish, because you just got to hand stuff in. Hand everything. Give it a try, or come and talk to me, or better yet, watch the video and just click, stop the video, click, whatever. And if you have a problem, email me and say, I'm stuck here. No question's a dumb question. I like easy questions. Oh no, you just forgot to click the red button to start it. Oh great, that kind of thing. But no, it's there's, it's all in this class. It's always an issue somebody's had before. It's always, and if you're asking the question, I guarantee you there's other people that have the same question. It's just that you didn't know they asked, that they're also asking, or they haven't yet been able to formulate the question, and you're able to formulate the question. There's lots of reasons. So you're always helping by asking questions. This isn't important. The PowerPoint slides, this is where all the PowerPoint slides are, and I'm gonna go over these today. So I'm gonna download this right now. Okay, and then sample programs. Yeah, there's a bunch of sample programs here. I think these are the sample programs actually from the textbook. And inside a sample program, I think you might have the, okay, let me just look and see what chapter 1 sample program. So the assignments are gonna, oftentimes it'll be start with the program in chapter, let me see chapter 3. I might as well do 2. All right, let me go here and let me open up this and open up thaw space. Okay, let's look at, all right, let's just start with chapter 1. No, let's start with chapter 3. There's probably nothing in chapter 1. Extract all. So in here, okay, there's a bunch of programs. These are programs. Oh, look, there's images. We're going to learn how to write a program to flip coins. So let me see. So we go in here, and we go in here, and you have to answer this question. Okay, yeah, okay, so we're at 2017 now. So this might be professional, but you don't need to use, wait, no, I don't think this is professional. I think this actually is community. All right, let's see if it asks me to log in. It might not ask me to log in. After a month, though, it'll start asking me to log in, and every time. All right, well, that starts up. So that's that. And those sample programs. Okay, and our assignments, the assignments will be here. There's going to be about 10 of them. I have them all ready from last semester. I'm going to make adjustments to make them better. And this is the grade book, and all the stuff's going to go here. These quizzes are going to go into quizzes. So I have to move those. So if you look at the tests and quizzes, they are online. Yeah, I have to sign in. So I will, you might as well see this, richardh@hawaii.edu. And see, I have 2 of them. I have no idea what the one they gave me here is, which it probably has professional or enterprise or something in it. I suppose I should figure out what that password is. I remember this password, I think. All right, so while that's starting up, oh, we're here. Did I just close it? Oh. All right, anyway, I'll get back to that when we get into the lecture. Okay, so quizzes. So here's a quiz. This is what the quizzes look like. So you read chapter 1, and you can take the quiz, and you take the quiz as many times as you want. You take the quiz, and it'll tell you the score. You take the quiz, it'll tell you the score. It won't tell you which one. I don't think it tells you which ones you got wrong. It certainly doesn't tell you which answer you got wrong, or it doesn't tell you the right answer for positive. But I think it doesn't even tell you which questions you got right or wrong because of people that, I have a Monday class and they do the same thing, and someone emailed me and said, I've tried every answer for the last question and I can't get it right. I still only get 8 out of 10. And I go in there and look and go, oh no, it's not the last one you're getting wrong. It's 2 of the other ones you got wrong. You got, and then, yeah. So if you're, I mean, what you want to do is you want to take the quiz early enough so you can take it a number of times. After the due date, you can still take the quiz all the way up to the end of the semester, but you can only take it once. Okay, you got that? So, all right. So and that's the incentive for doing it on time. I like to incentivize, and I like to give you an incentive to do it on time, and then the people that are diligent and all that do that. But I don't want to. I mean, I want you to do the work, okay? So I'm not going to say, sorry, you know, you had your chance to learn. Too bad for you. You know, that's just not a nice way to be. When a computer is performing tasks that a program tells it to do, we say the computer is running or executing. I bet you that's the answer. Next. Drive stores data on a simulated disk drive, but has no moving parts.
Oh, USB heads.
I think that's what it is. All right, anyway, so I don't want to tell you all the answers.
Instructions.
Yeah, that's what it is, all right. Yeah, so you guys learned all this stuff already. So there's 10 questions, very simple. I'm not gonna, I mean, I think those answers are right, but. Oh, I think the ABCD, I think it's randomized too, so. You can't just remember, you can't just text your friend, oh, question 4, the answer is C. Yeah, go ahead and do that. All right, so quiz 1 and quiz 2 are up there. All right, and the only, you know, I don't want people to, you know, in the first part of last semester, the first time I taught this class last semester, first part of it, so I made it so, you know, you got to hand it on time, or if you do it on time, you get to do it again, and then you actually get like 3 weeks later or something, in case. And then of course you get people going, oh, I didn't get. Can you give me a chance to my dog ate or whatever, you know? And so I don't want to hear the excuse, you know. I just. And so it turns out that now this semester, the first semester, where I can go in and individually give individual people more time. Okay, but that just makes it unfair for everybody who doesn't come and ask me. You know, it's always for us instructors, it's always the favorite student that just sits there and shuts up and doesn't give you any trouble. But those are the ones that suffer. So if somebody, if you know, just all it takes is one of you say, hey, I'm pretty sure the answer to that question is wrong. Can you check it? All it takes is one of you, because if one of you finds it, don't worry, you're all gonna get the benefit. So if somebody does, you know, there are deadlines. Somebody does come and talk me into extending it for them, you're going to find it extended for all of you. Okay, so well, unless it's something where you would legitimately bring a doctor's note, I guess. I guess that's a reason why I could give you special. But I try to absolutely minimize the cases where that would be the case. But I'm always flexible. All right. So that's pretty much an overview of the class. One thing you can do with your Dropbox is you know, you can bring a USB drive around if you want to, or what you can do is you can just do everything on the desktop, and before you leave, you zip the whole folder up again and you upload it to your Dropbox. And that way you go home or go ever, come back the next day, come back the next day and you're on a different computer and you forget your USB drive, it's still there. And so you may be thinking, well, last semester, a few people really had trouble knowing what to save. I'm going to want you to upload your whole solution, your whole project file, so I can open it up. I won't. I mean, in the beginning, I might not so much. I might just open up and look at your code. There's a couple of files that where everything you do is going to be in the 2 files in there. And that's how I did it in fact, the last semester I did it that way only. But I found, okay, so then I bought a new computer at home, and I found that I could just download your project, unzip it, pop it open, and look at your code in like really fast. Okay, I discovered the value of having a super fast computer finally. I used to always buy the cheap one, the cheapest, you know, because you do web stuff. But anyway, so it, fast computers sure are more expensive, though. I gotta admit. All right, so it's we have about a half an hour. I don't think it'll take that long. I'd like to go through the slides. The first here, it's right here. Okay, so this is chapter 1. We're gonna, let me see if I can do this view, no, slideshow. I'll do this, and I'll do something else too. I will put it on your screen. All right, I want to, first of all, let me exit this. We go like this. Huh? Oh no, but first I'm going to put it on your screens, because in case those things go out. And see, how do I do this now? Don't tell me. I put this, and I do. No, wait. So what's going on? What am I not doing? I'm currently viewing all oh, maybe this will come up later. What is this? Well, I don't know why it's not working. Okay, so I won't do that. All right, so yes, I'll do what you, I'll go slideshow, and I got to do this display settings swap thing. All right, that looks good. All right, so this is the first chapter, so we're just going to introduce hardware, software. It's all stuff you know already. It's only towards the end to read. A program is a set of instructions. Programs are commonly referred to as software. If without software, they can't do anything. Programmers or software developers create software, trained for it, design. Oh, I got it. Back, let me do this. Okay. Software developers create software. They have training and the skills necessary to design, create, and test programs. This book introduces the fundamental programming concepts of C#. Hardware refers to physical devices, usually many pieces of hardware to make up a computer, all working together. We typically have a CPU, main memory, disk, input devices, keyboards and mouses and pens and screens, and output devices, printers and screens, and sound. CPU is a microprocessor. It's a chip that's gotten bigger over the years. Most important part, arguably the most important part of the computer, and these are two of the common CPU vendors. There are others. Main memory is RAM. That's where program stores all of the programs, program instructions, and the data that it's accessing while the program is executing. Random access memory. What that means is you can access any location in the memory in exactly the same time, no matter where it is. You can randomly access memory. It's going to take exactly the same time, no matter how far away it is or how close it is. And RAM is generally volatile, which means that the power has to be on for it to be able to store. It takes electricity to store it. Turn the power off, the it can't store anymore. It goes away. Secondary storage devices are like disks, and they are non-volatile. These are volatile. Disks are non-volatile. Disks traditionally have been magnetic. They're on a something that spins. The magnetic coating and the bits are stored with magnetic spots, magnetized north or south. Thing spins around. There's a thing that reads it. Goes in and out and reads tracks, sectors and tracks off the disk. Solid state drives look like disk drives to the computer, but they're not implemented using a motor and some disks that are coated with magnetic coating and have heads to read off the magnetic spots. It's not like that. By the way, disk drives are not random access, because clearly if your program is requesting data that's close to where the head happens to be at the time, it gets it fast. If it's requesting data that happens to where the head's got to go all the way, except it goes all the way to the other side of the disk and so on, then that can take longer. Solid state drives, it's the same as RAM, except for it's non-volatile. It's actually not random access, because random access memory you get bytes of memory, or you get memory values out of the memory. Either in the old days it was 8 bits at a time, a byte at a time, and then became 16 bits at a time, 2 bytes, and now it's usually like 32 bits, or that's 4 bytes at a time. And then now we have, you've heard of 32-bit, and 64-bit. Now it's 64 bits at a time. So, and that's fine, because we have operands, we have numbers that are actually take that many bytes. And so, so you can still think of it as random access. You can get any set of 64 bits at any time. With solid state drives, it's stored using the same kind of semiconductor technology, but it's not like 64. It's like a whole. It's still you stream the data in, and then it stores like 1024 bits right in one chunk, and streams some more data in, and now of course it all happens really fast and everything, and it's solid state, which means it's electrons traveling through silicon, which travels about a third of this, well, about it's pretty fast, maybe a third of the speed of light, or so I don't know, maybe it's faster than that. Whereas with magnetic disk drives, you got the spindle rotating, so you got a motor in there. And then of course it uses a lot less power. It can use a lot less power because you don't have a motor. You're charging up transistors. And then there's DVD ROMs and USB drives, which is like this technology, except for it's in a little thing that slides into a USB port, and SD memory cards. Input devices are things that take in data from people, but also devices. Anything that gets data into the computer, touch screens, microphones, mouses, scanners, and so on. And output devices, as you know, are like printers, screens, speakers. Software is categorized as system software and application software. Okay, system software are programs that control and manage the basic operations of the computer, operating systems, utility programs, and software development tools. And application software is, okay, so software development tools, that's Visual Studio. Utility programs, that's probably things like, I don't know, Yeah, Task Manager. Is that kind of part of the operating systems? But yeah, operating system, it includes the whole package, all the stuff that's Windows. you can have a machine like that that doesn't run Windows. It runs something else, Unix, and a Mac is a machine that looks a lot like this on the inside, but the operating system is different. So that's operating systems. And application software all run on top of the operating system. So you need to have an operating system, but so you need to have Microsoft Windows before you can run Microsoft Word or Microsoft Excel. Now, C# is used mostly to write application software, but a lot of parts of these other things, especially this, I'm sure, C. Okay, Visual Studio is probably written in C++ using Visual Studio. So, but the language that you learn is C++ is a like more primitive version of C#. There's a bunch of features C# has that C++, but it's still object-oriented. And you'll learn what object-oriented means. I'm somebody that started programming before there was object-oriented programming. It was called, there was an intermediate kind of programming called structured programming. And then before that, it was just like spaghetti code, and go-tos and all this kind of stuff. And you'll learn what all that means. But with structured programming, you learn to think like you would write a program using object-oriented programming. You think of little programs and the data as being one. You have the data, and then you have the little programs that operate on the data, and that's one unit. That's an object. And then you have these objects around objects calling other objects. But a lot of the programming is associated right with the data, and you can't really get at the data. You have to use the little programs associated with it to get to the data. And by doing it that way, and of course some other team, some team is writing the objects, and some other team is writing the code, some other application code that's using the objects, and so it's a way to protect data from ever getting corrupted by somebody writing the wrong thing in some data location. So structured programming, and that was languages like Pascal. And we learned how to think that way, but still it was all in our mind. We wrote our little subroutines, and the subroutines we made sure that only this subroutine accessed this data, and so on. And when I taught ITS128 back in 1994, we used Pascal, and that's how I taught. I mean, and then object-oriented programming came along, and basically it forced you to write code the way that we all tried to write code in using structured programming. And so you don't have any choice now. You have defined classes, and inside of classes, access classes, and inside the class is the methods that access they changed the name of everything too. It's not called a subroutine anymore. It's called a method. The methods that access the data, and it's actually restricted. You restrict it. The default is it's restricted, and you can unrestrict it if you want to, and so on. We'll see how we'll see all that, and because of my history, I'll be able to share a little things about how it used to be. And as you know, computers store data in sequences of ones and zeros. Back in the old days, they tried three levels, because if you can take a bit and store 3 states in it instead of just 2 states, then it doesn't take as many digits for a number. That's why 10-digit numbers for the same values uses fewer places than a binary number. But binary is the best. On and off is the best. And so with ones and zeros, we just we combine those up, and we can take 8 of them, and groups of 8. That's bytes, and and we define this thing called ASCII. And so forevermore ASCII, if it's this, which is 1000, oh, it's probably a 0 here. I don't know why you erase it. 01000001 is it converts to ASCII 60 to decimal 65, which is the code for capital A, and code for capital B is 66, and so on. So that's just a convention that they had a long time ago, and we still use that convention. Digital refers to anything that just has zeros and ones, on and off. Programs execute. Time is it? CPU reads instructions written in machine language. A program will be copied into the memory for the CPU to execute. Copies from a disk to the memory, and then the program executes it. And CPUs, there's this is not that important, but you probably learned this in 101. This fetch, decode, execute cycle for processing. The CPU fetches the instruction, decodes it, figures out what it means, add 2 numbers, and then does it. And then it goes on, fetches the next instruction, and decodes it. Oh, this is subtract, and then does it. Fetch, decode, execute. Machine language, that's the lowest. That's a sequence of 1s and 0s. Assembly language is next. Okay, assembly language, people write assembly language. If you're a gamer, if you write gaming code, and you probably write it in C# or C++ or some language, Python or some language, and then there's a section that's got to be really fast, and you can't write it in C# because all this compiling high-level language down into the intermediate code, and then that gets translated down to the 1s and 0s, and there's just too much stuff that gets stuck in along the way because, well, I mean, if it turns out that just by merely structuring your code like that, to call for one method or one program to call another program requires you store a bunch of data onto what's called the stack in memory, and then you go execute it, and then when you're done, you unstore all that back into unstore all that. And the reason you do that is so when a program that you call a program, you want to let that program be able to use all the microprocessor registers and all that. So you store out everything, and you give it to a new program you give the CPU to a new program to execute. And then when that program's done, it takes all the old data and puts it back, and then it returns to the program that called it. I don't know if you understood that, but that all takes time. Well, if you want to skip all those steps, you got to go down to assembly language. So you use Visual Studio, and what you do is I sometimes teach ITS128, which is the assembly language programming class at Manoa, and we use Visual Studio, and we use C# C+, or what, C+. And in C+, it's got a bunch of facilities to write assembly language code also. And so that's what we do. And we're writing these, add A, load register B, add register A to register B, store register A out in memory location. So it's that kind of stuff. And what a compiler does is it takes, when you're writing programs, you have you assign a variable equal to an expression, right? You got this expression on the right side, and you got a variable, and it's like evaluate the expression, store the result in the variable. And so when you're writing lines of C# code, that's what you're writing. Well, one of those statements has to be translated down into a series of those assembly language statements. And so like one assignment statement might be 10 or 15 assembly language statements that all execute. And the last thing that executes is storing the result into the to the variable that's being assigned a value. And there's there should be, the old days, there was a one-to-one correspondence, a one-to-one translation between assembly language and the ones and zeros, okay? Now it's not quite that way anymore, but it's as close as you're going to get. There can be some kind of prefixes, and there's some sort of assembly language things where you can like repeat the assembly, like there's special assembly language instructions where if you got a block of memory here and you want to move the block of memory over here, and it's all one contiguous block, it's just one instruction, and you say you have another register which says what the addresses are, and you say go, and it will fast. And oftentimes those kinds of instructions are not utilized in a high-level language because it's only a very well, it's actually the compilers are pretty smart. But you can always do better if it's a little chunk of code that executes 95% of the time. Then you go and you write that little code in assembly language, and it speeds up your program by 10 times or something. This just says there's keywords in Visual Studio, so when you're writing your programs, there's certain words you cannot use as variable names. Yeah, that's how it is. Understandable. You don't want to confuse the programmer. You don't want to confuse the compiler. So there's a difference between compiling and interpreting. Okay, a compiler actually takes your program that you wrote, and you're going to be writing these C# programs, a bunch of lines of code, and then it takes it and reads it all up, and it takes multiple passes over. It builds, creates some intermediate files and so on, and then produces one big assembly language program or one big machine language program that does the whole thing. And compilers are smart enough to know, like, if you have a loop and inside the loop you're assigning some variable to some constant value, and you don't do anything else with it inside the loop. Sometimes you might do that, and you realize, you don't realize it, but the compiler realizes it. Hey, they're assigning I equal to 1, like every time this loop executes, and so each time it just says I equal. So why don't we take that I equals 1 and put it right outside the loop? We'll put it right above the loop, and then it executes once, and then inside the loop it's going to be I. So the compiler is smart enough to know all that stuff, and so that compilers, good compilers will actually take some code that you wrote that's maybe not as efficient as it could be and make it more efficient. Whereas interpreters, they are like compilers on the fly. So you have a program like Python. I think Python is interpreted, where you got these 10 Python statements. And okay, now this is a real simple kind of interpreter, where each time the Python's, and it could be a loop, okay? So this got these 10 statements, and they execute 5 times. The loop executes 5 times. Each time the statement is to be executed, it's compiled. So it's translated into the machine language and executes. Takes the next high-level Python statement, translates it into a bunch of machine language and executes it. Takes the next one, translates it into a bunch of machine language and does that. And so then when it comes back around the loop, it does it all again. Okay, now this translation is really fast, so you don't use lots of times you don't really notice. But of course, in a real high production system, you don't want to have interpreters, you want to have compilers. And so now in the real world, it's not the entire complete text Python statement, but it's pretty close. The whole Python program is converted into something that's easier to read for the machine. It codes up stuff, puts symbols and codes and stuff in there, but it's still the same basic program, and then it does the translation that way. One thing about interpreted programs is if you want to do something that you get a bad grade for if you're writing, but you could have your program modify itself. So it's like you could have the program down here change a plus sign to a minus sign, and then it comes down and executes it. It's different, goes back. So it's possible to do that kind of stuff when you have an interpreted program, because because the line of code is going to be, you know, interpreted all over again the next time it executes. And there's other times when if you want to get around something and shoot. So I'm just going to have this code write a little program to be executed down below, and so it does it, and then it calls it, and that's kind of cheating. But you know, you should never have code modify itself. But you know, sometimes you do it. Oh yeah, it says PHP, Perl, Python, and ASP.NET. That's the web version of it, and it's because, you know, you're writing code and then you write code and you execute, and you write code and you execute. Interpreting is a lot faster because it doesn't hardly have to do much. It does everything on the fly, whereas compilers can take a while to compile. And graphical user interface, of course, is, you know, this is what it would look like, you know, with the command prompt. In the old days, this is all we had. And in Java, when you code in Java, you're writing a lot of stuff like this on a black and white screen like this, and it kind of really is a lot like this. But you know, it's still not quite like this. And then of course, this is a GUI, and in this class with visuals, you know, we learn how to make these things. You know, we can make this thing right here. I'm not going to, but you know, with all these things up here and so on. Probably in 148 we'll cover that. And then there's these things called objects, and all objects are is it associates the methods or the programming code with the data itself. The data is like the properties, and the methods are like operate on the properties. Properties are data stored in the object, and methods are operation on an object that an object operations that can be performed on the object. So here's so this is a form object. Of course, actually, these are also, anyway. Controls are these things. These are called controls. That's the name of them, controls. They rename everything. They come up with a new programming paradigm, and they got to make the language all confusing. And you know, there was a guy that took this class last semester, and you know, he's a Navy guy, and you know, very experienced. You know, been in very, you know, situations and everything. And he comes and he's this language. I just can't get this language, and he, you know, it takes a while, and you have to sort of, you know, try not to figure out why they call it that, and just say, okay, that's what that's called. And it's a new name. Or it's a, you know, this is the name. This name is like it's like another name for something else, but it's not the same thing. So and if you kind of have that, there's in programming today, when you start out, especially in this class, when we write our first programs, there's going to be a bunch of lines of code up there at the top. We go, what, you know, and we're not even going to talk about it. Okay, well, I will, but you know, they're called classes, and we don't really start paying attention to building our own classes until like the very end of the semester. But and you know, the book kind of introduces, okay, now we have a new concept, a class. Well, we've been using classes all along. They're up at the top, and you have to know about them. Whereas in the old days, back when I first learned programming, all there was coding. You write lines of code. There was no anything else. First thing you write is something that the thing's going to execute. There's not any of the setup stuff or anything. And it was a lot. There was a lot less you had to keep. There was a lot less you had to take on faith. Now you just have to take stuff on faith. And the trouble is when you're learning this stuff, like Visual Studio is like a hog. And if you're on a slow computer, it can take a long time. And you try to run something, it's like nothing's happening. And you think there's something wrong with your program, or you didn't do something, or the thing hung up or something. Then finally, it starts doing stuff. Also, there can be times when things are starting up and they don't start up in the right order. And then something happens, oh, it's not there, this thing is missing. And you think, oh, no, my installation didn't work. Well, you just try it again. It's software shouldn't be that way where you try it once, it doesn't work, you just try it again and it works. I mean, that's hardware. Hardware is like that. Oh, jiggle it and it works. You know, it's software is, it's like Microsoft code is kind of famous for that. But after a while, you learn about multitasking and stuff, and then you kind of can see how it's possible. And the .NET framework is just a bunch of classes that allow you to interface to all kinds of stuff, interface to the disks and all that, so you don't have to write any code. You just, there are these objects that are up there out of nowhere, and there are these methods that you call the methods, and they get the data for you from the printer or from the disk or whatever. Algorithm, pseudocode, these are just these are things that we might do aside from writing the actual programming code. You can flowchart the logic of your code first. You can write pseudocode, which is like programming, and then the algorithm is the actual the mathematical steps that, like a sort algorithm. There's 6 different ways of, well, there's more than that. 6 basic different ways of sorting that you would learn if you were taking like 211, or you might. We're gonna learn a couple of sorting methods in this class, and so the algorithm is different. Pseudocode is not so important anymore because the programming languages that we use are so like English style, and pseudocode is what we used to use. Like if you're writing assembly language and you're sort of scratching out your code before you actually sit down and write the, then you write pseudocode. It's easier than flowcharts, because with flowcharts, you're drawing a picture of something. So Visual Studio, well, there's the designer window solution. We'll see that more. Where are we? 24. Getting close to the end. Okay, so this is designer form. Let me see, Solution Explorer, properties window, pinning, toolbar, toolbox, saving, docking, floating. All right. So so let me show you. I have this. How do I get out of here? So I have this Visual Studio thing up here. I'll just quickly show it to you. So this is a program I just opened up out of the. You have this too. I wonder if this does anything. Let me start it. I'm going to run it and see what happens. Click the start button, and it builds and compiles. And what happened? There's a. There it is. Here it is. Yes. So here we go. What is this? I don't know what I'm doing. 100, 200, 300. Calculate average. Oh yeah, that's average. Clear. Okay, so this is a little program, right? And so we can go over here and click on this double form.1.cs. That's the default name for form. There's the form. There it is. Now I can right-click, view code, and so here's form1.cs design. This is the designer window, and then here's form1.cs is the code window, and this is all the form class. Form 1, it's a form class named form 1. That's this. It's a partial class because this design, I was telling you the design. You're actually producing this. This is the other partial class. See, this is click this thing. This is where all the labels are, and see, it's got the coordinates of them. This is the text boxes and so on. When you manipulate this thing, you're actually producing this thing. This is the file that gets compiled. And as this is where I said, if you use a Mac, if you get Mac Visual Studio, they have Visual Studio for the Mac, but it does not have this thing. When you design your form, you got to write this code. So I could have a class like that where no, you got to at this level. This is real coding, but we don't have to do that anymore. This is very developed. And so there's a toolbox here. Wait, let me click on this thing. Oops. Toolbox is these are all the tools for. Now I can pin it. Now it's over here on the left. And these are all the controls for this thing. See, I can, you know, throw another label on there if I want to. So that's how that works. And then over here are the properties. I just put another label there. So that's the properties I see. It's called label 1. This is what, you know, Joe. Now it says Joe. It's a text. The label's got a name called label 1, and you might want to change this to LBL Joe or something because it's LBL. That's the name of this label. This is a text box. You know, anyway. And then this is the Solution Explorer. It's where we saw the files, properties, and so on. So it's 4:30. Sorry. Oh, this class goes to 4:30, right? So this is just an introduction. You can watch this video later. Just take a look at chapter 1 and try out the quiz. Try out the quiz early because you can take as many times as you want when you do that. And I will, let me stop sharing, and I will see you next time. Thanks for watching. I'm going to put this video up on La Lima.